My name is Donnie Prakoso. I'm a technology evangelist working with AWS, covering for ASEAN. And today I'm going to share, this is kind of like a special session for me, because prior to joining AWS, I was CTO for 4 startups in Indonesia. So I've been dealing with microservices from small scale to large scale. And in this talk, I'm trying to collect all those experience into a set of best practices. And you will see that I've incorporated the 12-factor apps into my sessions. So, and today we're going to have like a 50-50 of slides and also the live demo. I'm going to show you how to build the application from scratch and using AWS Fargate. And also how to coordinate those microservices. So for today's talk, it's all about microservices. So quick check, how many of you are working for startups? Okay, and how many of you are developers? Nice. Handful room full of developers, my favorite. So let's step back. What is microservices? So I'm taking this definition from Martin Fowler that it's an approach to develop applications. It's a suite of small services. It's running its own process, running its own business logic, and it's communicate one to another, usually with lightweight mechanism, usually HTTP, but I've seen few are using gRPC as well. So this is the basic of microservices. And to give a big picture, this is a diagram to show you the difference between monolithic and microservices. You see, let's say for an example that we are building an e-commerce applications. In e-commerce application, we need to have an UI. This is the front end. And then we have to build the order service, inventory service, shipping service, and then we package it in one large code base. And this is how monolithic approach works. Oh, it doesn't work. So with microservices approach, we pull out those services into specific services, like order UI. We build out one single service only to manage the front end. And then we have another service, which is shipping service, and then inventory service, order service. So basically, we only need to pull out each services into specific services, but they still communicating one to another. So this is a big difference between monolithic and microservices. So I know that there's been like a discussion, which one is better, right? Monolithic approach or microservice approach? My take is there's no such thing as a better approach. So sometimes we need to build an application using monolithic approach. That's fine, totally fine. And sometimes we need to do the microservice approach. That's fine. But because in this era, when we build an applications, it's more we need to adapt to the real request. Like you need to scale out in an instance. And with microservices, you're getting a lot of benefits. So as for example, if let's say that you have a marketing campaigns running and it's going to hit your front end. So the one that only need to scale out is only the order UI, right? But if there's another payment request, it's going to scale out the payment service as well. So that's the benefits of using microservices. And I know there's a discussion going on, but I'm taking tenets of microservice architectures. It's decentralized, it's independent, it's black box, you do one thing well, it's polyglot. So these are also tenets, and also I think it's one way to describe the benefits of using microservices. So with microservices, you build one independent service, right? This independent service, and then you decentralize it. And by nature, we can call it this as a distributed system, okay? So, and the best thing for me when I use microservice approach is that I can build any kind of service using a specific programming language. Okay, I can build something using Go language. I can build the front-end UI using Node.js. I can build the payment service using Elixir. So it gives us the freedom Because if you ask me, I'm not a fan of specifying one specific programming language. I fail to see the supremacy of one language. So with microservice approach, that we're taking out the benefits of each programming language and incorporate those into our applications. So Polyglot is giving us Polyglot standards, giving us the freedom of building system as much as we want. So, and these are the benefits of microservice architecture. It's give you the agility and give you a flexible scaling and easy to deploy as well, because once you deploy one service, it will not necessarily affect another service. And it gives you the technology freedom, and you can reuse the service that you've just created for another purpose. So I'm going to show you demos on the reusable code and flexible scaling today. And it also gives you the resilience of your applications. So this is the, this is the guidelines that I use. So it's called 12-factor apps. So any one of you have heard or actually implement 12-factor apps? Oh, nice. I think you guys should be here. Okay, so 12-factor apps, for those who don't know yet, is a guidelines. It's a collection of best practices from software developers, engineers who already scale their systems, and then they put those guidelines into 12 best practices, starting from code base, dependencies, configurations, up until admin processes. So I've already provided this link over there, 12factor.net. It's very useful, and I found it very useful when I want to build an application. So if you are on developing something, an applications, and you just started off, or you want to do refactor your systems, I suggest that you take a look on 12-factor apps first, and you will get benefits of doing this modern approach of software development. Okay, when talking about microservices, I always get these questions. What are our computing options? Yes, we can do on traditional approach using EC2, spin your instance, and then you deploy your microservice. And then we have another approach, which is serverless. And I do understand this is the containers event. We can use the containers as well. So when we want to pick our options, when we build applications and we build this Docker image, running this application in a single host is very easy. Okay, so, but how about a few hosts? Okay, and then how about if we deploy it into many hosts? So this is actually a problem that I see when it's dealing with a distributed system. The real challenge is that we need to expect that we're going to have a distributed problems. Okay, so that's why we need to use an orchestration tool to manage everything. And this is where Amazon ECS kicks in. So with Amazon ECS, you don't need to worry about how to manage all those instances running your container application. It's a highly scalable, high-performance container orchestration for those who are running Dockers. Okay. So ECS has this production benefits. Like if you want to have an advanced task placement, let's example that you put your containers across availability zones, or you want to put your containers on the least service, you can use the bin pack. And with Amazon ECS, you can also have the integration with AWS platform, auto scaling, CloudWatch, everything. So you have everything in this service. Amazon ECS also helps our customers, starting from Atrol and GoPro. And this is one really good example from our customers from BuzzFeed. They've been building a platform on Amazon ECS. Just imagine this, 400 services with 80 container instances, 50,000 deploys. They have 6 clusters across 2 regions. Okay, so this is how Amazon ECS helps our customers. It makes it easy for them to manage and orchestrate their containers. Okay, so also that we have 63% of Kubernetes workload run on Amazon Web Services. So we have EKS, this one. If you prefer to use the Kubernetes, you can use Amazon EKS. Okay, so, but this is actually the feedback when I talk to developers, right? If we have more microservices, that means that we're going to have more containers. But does that mean that we need to do more operations? My feedback is no. If you have more microservices, you can have more containers, but it should be less operations. Okay?
Foundry, right now, Cloud Foundry. If it is cloud native, if the load workload is not cloud native, yes, I need to bundle it into a image and put it on containers, right? Why would this be my first choice if my application is 12-factored? I could
understand. So I think that's really good questions. But when it comes to in real life, that it's not necessarily that we need to brand our application as a cloud native. We have different use cases. Like some of them they want to have like a hybrid infrastructure. They have own data centers and they have like a multi-cloud. So that's why this can help them to scale out the applications. So to answer your questions, when it comes to microservices, it's not necessary to brand to be like cloud native. More and more, our customers, they want to have these tasks or containers as their fundamental compute primitive. Okay? So I think this is a really good era for us, that we move from depending on source code applications, right? And then we have this immutable Docker image. And then we use that Docker image to deploy our applications. So more and more, our customers, they want to rely on these containers, their tasks. They don't want to be hassled into managing their own infrastructure. Okay, so that's why last year during re:Invent, we announced AWS Fargate. AWS Fargate is a service that can let you run containers without managing servers or cluster. So it's super cool, it's super awesome. Let's think it this way, that with Fargate, you only need to define your task definition. You only need to define the CPU and memory configuration, and also the volume point, and you refer them to the exact Docker repository, and then that's it. You run your applications. So to think about it, it is a serverless way to run your containers. Okay, so how many of you have tried AWS Fargate? Okay, so I think it's going to be useful for the rest of the audience here. So with AWS Fargate, you can see here the most benefits is there's no instance to manage. It's leveraged the task native API, and it gives you a different pricing, which is the resource base. So with Fargate, you only need to define your CPU and memory allocation. So I don't think this works. I mean, this slide's supposed to show you with Fargate, you don't need to manage all those EC2 instances. It's all being handled by AWS Fargate. Okay, so and then another question is how to manage code lifecycle. So the heart of the modern approach of applications developments is we have this continuous integration, continuous delivery, or continuous deployment. So this diagram shows you the difference between those three terminologies. And I'm going to show you how to build do the continuous deployment from scratch using AWS Fargate, code pipeline, and also code deploy. So these are the services that we have that AWS offers to you when it comes to CI/CD. We have code start, code commit, code build, code deploy, and code pipeline. And this is the diagram. This is the continuous deployment. So you commit your code into the code commit or GitHub, and then it's going to be send the webhooks to code pipeline. And the code pipeline, you can have two parallel branch that define the workflow for each branch. Like on top, you can have this code build to push the image to Amazon ECR, and then CloudFormation will update the stack and update service and into Amazon ECS, and there you have it. Okay, so another thing is about the CI/CD. Sometimes I got the feedback on how they can handle the configurations. So how many of you have your JSON files or config files on your applications? Okay, you still. And how many of you still using environment variables? Okay, so there's another approach, which is using the system parameter stores, using EC2 System Manager, that you can have these centralized configurations for your applications. So with this, it's really flexible. You don't need to package your own configuration files. You only need to point to this parameter store, so you have your centralized configuration. Okay, so another thing is how we can handle the secrets. So, and how many of you hard-coded? Okay, it's a moment of truth. How many of you hard-code your database username and password into your application? Okay, I saw you. You're a bad boy. Okay, so AWS has this service called AWS Secrets Managers. So what's the big difference between AWS Secrets Manager and System Parameter Store? With Secrets Manager, it gives you the flexibility to rotate your password. So you don't need to manage your password and then you glue it into your applications anymore, one by one. You don't need to do it. It's a centralized. So these two services have this characteristic. It's a centralized configurations and centralized secrets manager. So when it comes to updating those configuration and those secrets, you don't need to redeploy your application because it's going to be, you can change it on the fly. Okay, so I'm going to show you how I can build this, how to do the CI/CD, Secrets Manager, and also Parameter Store. So I have this app, a simple app. Can you see it? Okay. Okay, so this is a simple applications to show you how to build this, how do you call it, like the web apps, like a Hello World, but taking the configuration from Parameter Store and also the Secrets Manager. Okay, so you can see here, it's a simple Hello World, and I have this Secrets Manager here, calling this AWS Secret Manager, and Parameter Store here. This is the functions, the basic function that I use to retrieve the configuration from AWS services. Okay, so, and then, let me show you. Oh, okay. So this is System Manager. I have all this configuration for my application listed here. Okay. In my, you can use JSON, you can use any YAML, or you can use TOML, right? So this is the configuration file for my application. So, and when I run my application, like, okay. As you can see here, this configs is retrieved from System Manager. So, and also the secrets, it's retrieved by the AWS Secrets Manager. So it gives us the different perspective on how we see the CI/CD. That now we can have the centralized configuration for our applications. So once we update these configurations, it's going to be automatically applied to all of your applications. Okay. So, and then let me try to change this code and do the CI/CD. Okay. So I'm going to change this hello world to hello container conf. Okay. So, and then, as usual, that we need to commit our code. We check this first. Okay. Demo on stage. Okay. Now we just commit our code, and I expect that it's going to be trigger a CI/CD workflow. So here is the code pipeline. So as you can see here, once that I commit my code, it's going to be pulled by code pipeline, right? And then after that, I'm going to build using code build. And now this is the moment when I want to build Docker image. So whenever I do my development for my application, I don't push the Docker image locally. Instead, I'm doing it on code build. Okay, so after this code build success and passed all those tests, it's going to push to Amazon ECR to create the Docker image, right? And then what I expect next is this ECR will be called by Amazon ECS to deploy the applications, right? So this is the idea of CI/CD. As you can see here, that we can check the details. Okay. You can see here, this is actually the Docker build running. And after that, it's going to push to AWS Fargate. Okay, so to give you a big picture on how AWS Fargate works, is you can see here, I have this. Okay, so up. Yep. Yeah. So while we need to wait for a while for the code build. Okay. Now you can see that everything is completed here, and when we see the code pipeline, it's going to deploy to Amazon ECS. We have this microservice Fargate, and when it's done calling this Amazon ECS, it's going to do the automatic deployment. So this automatic deployment is still waiting, and after it's done, you can see the task is going to be created here. Okay. So I only have 6 minutes left, but I still have a lot of things to talk to. So, okay, so this is actually how CI/CD works with, okay, you can see here, it's still professional. It's still how CI/CD works with Amazon Fargate. And that's it, that you only need to deploy your application using Fargate, and Fargate will handle the rest. Okay, so another thing that when it comes to microservices is actually on how you can coordinate your microservices. You can have like 10 of your microservices. You can have like 20 to 100 of microservices. Okay, but the only problem is not only how you can deploy and run your applications, but how you can coordinate them. So AWS has this cool service called step functions, which I'm going to show you the demo here. So if anyone of you have QR code, please scan this QR code, or I'm going to do a selfie, right? And then I'm going to do photo image manipulation. I'm going to send it to every phones that you have. Okay? So step functions, it helps us to coordinate our microservices. So you can see on the right side of pan, you can see this defined workflow starting from publishing the topic, and then it's going to publish the message to WebSocket, and going to process the image and publish the image URL. So as you know that these services is independent. They don't know the state one to another unless we tell them to do so. So with step function, it helps us to coordinate microservices. You can have like a simple workflow to a really, really complicated workflow. So let's do a selfie. Oops. see. Can I have everyone here? No. I'm really bad at selfie. Sorry. Okay, so 1, 2, 3. Okay, got it. So what I'm going to do now, I'm going to upload this photo to Amazon S3. And from Amazon S3, it's going to trigger the step functions to follow the workflow that I have defined. So let me resize it first. Okay. Everyone already opened the page? You can see that it's going to show you this page. Sorry. Yeah. Okay. So I'm going to upload the page now. Okay. So as you can see here, it's starting up. So that's it. So as you can see here, these step functions, it has this one surface to manipulate the banner of the photo. This done using AWS Fargate. And how it can push the photos to your phone is actually using IoT core, using MQTT protocol. So with step functions, those surfaces, they are independent one to another. They don't know unless that we tell them to do so. That's why we need step functions. So let me check. How many of you received these photos? Nice. Okay. So I think that's it. That's all that I have for now. My time is up. I only have like 2 minutes left. Okay, so thank you, everyone.